All right, so example 11.1.1, a hypothesis test with a chi-square test. So is there a relationship between autism and breastfeeding? So to determine if there is, a researcher asked mothers of autistic and non-autistic children to see what time period they breastfed their children. The data for 934 randomly selected infants is in table 11.1.1. Do the data provide enough evidence to show that breastfeeding and autism are dependent? And test at the 1% level of significance. All right, so again, our table 11.1.1 is the same table that we just had given to us at the start of the chapter. So our first step is to set up the hypotheses. And so again, the null hypothesis here is that we are going to say breastfeeding, timeline, and autism are independent, and the alternative is that the breastfeeding timeline and autism are dependent. So keep in mind what that means. That means that, given information about how long a mother breastfeeds a baby would give us information about how likely or less likely a child would to develop autism. And they gave us our alpha value here was 0.01. All right, so our next step here is to check the assumptions for the test. And in the paragraph, they told us that they took a random sample of 934 infants. Okay, the next condition is that the expected frequencies for each cell has to be greater than or equal to 5. So again, the ones that are highlighted above here, so these highlighted cells, those are the observed frequencies. So all of these are the observed frequencies. Okay, so each one of those is a value of O. Okay, so the expected ones we're going to see in matrix B after we run the test. So we're going to check values in matrix B after we run the test. And again, no population size was given, so again, we're going to assume that, the number of infants in the whole population is going to be greater than or equal to 20 times 934, which is a reasonable assumption. All right, so the assumptions have been met then for the chi-square independence test. Okay, in this case, we have two qualitative variables that we want to know if there's a relationship between them. Again, if we had two quantitative variables and wanted to know if there was a relationship, we'd be looking at the linear regression t-test. All right, so the fourth step is to find the test statistics. So on the calculator, we would need to first enter the data into a matrix. So we would go into matrix menu and move over to edit and choose 1 for matrix A. Okay, this will allow you to type the contingency table. We'll say here, contingency table into the calculator as a matrix. So figure 11.1.2 shows what you will see on your calculator when you choose that matrix from the edit menu. Now these may be different for some of you depending on if you've used the matrix before, but we're going to change these in a minute anyway. All right, so the given contingency table that we have has 2 rows and 4 columns. So don't include the row total column and the column total row in your count. Just enter the part of the table that is highlighted. So you need to tell the calculator that you have a 2 by 4. Okay, so that means here we need to put a 2 and here we need to put a 4. Okay, so this is the number of row categories and this is the number of column categories. So once we enter a 2 here and hit enter, and then a 4 here and hit enter, then it will open up a matrix that is 2 by 4. Okay, so down and across for those dimensions. All right, so now type the table in by pressing enter after each cell value. So that first cell where it's highlighted here, we would enter 241, and then we'd hit enter, and then we'd enter 198 and hit enter, and so on until we've got those 8 entries from the contingency table, so our observed counts. All right, so once you have the data in, we're going to press quit. Okay, and then to run the test on the calculator, we're going to go back to the stat menu and move over to test and find chi-square test in that list. And so again, the input screen for that, these should say A and B. Okay. Again, if they don't, we would have to change those, but default values there are A and B. And so again, as long as you put your observed matrix in matrix A, which is how we started, and the calculator is going to write the expected values to the matrix B for us, and we can look at those after we run the test. So once you press enter on your calculator, you'll see the results in figure 11.1.6. So again, here is our chi-square test statistic at the top. And then again, our p-value. And again, this piece with degrees of freedom, like I said, we are not using tables to look up values anymore. So for that number is not going to have any relevance to us whatsoever.